Hey everyone, and welcome to this explainer. I am super pumped you're tuning in today because we are tackling what is arguably the most absolutely crucial, yet somehow completely overlooked, piece of modern AI engineering. We're going to look at exactly how you take those messy, unpredictable AI prototypes, the ones we've all been playing around with, and actually turn them into reliable, production-ready applications. And the secret sauce to making that leap? It all comes down to mastering evaluation.
So let me ask you a question. How do you actually know if your AI works? It sounds like such a basic question, right? But it is a massive industry-wide problem right now. Think back to the beginning of the ChatGPT fever. Companies everywhere were rushing to deploy these customer support chatbots, just totally caught up in the hype. But the stark reality today is that a lot of those same companies are sitting there entirely unsure if their chatbots are actually helping their customers or just actively ruining their user experience. They built the thing, for sure, but they never actually figured out how to measure if it was successful.
Okay, let's dive into this. Here is our roadmap for tackling this engineering challenge. First up, we'll look at the AI evaluation bottleneck. Then, we'll shift gears into evaluation-driven development, define your evaluation criteria, talk about automating with AI judges, and wrap up by navigating model selection.
All right, kicking things off with Section 1, the AI evaluation bottleneck.
We have to acknowledge right out of the gate that current AI has totally lowered the barrier to entry. I mean, you can build an AI app today without writing a single line of code. Building is easy now. But AI engineer Chip Huon really hit the nail on the head when she said, "I believe that evaluation is the biggest bottleneck to AI adoption." While everyone is sprinting to build apps, creating a reliable pipeline to test them is the actual key to unlocking these game-changing applications. If you can confidently evaluate it, you can confidently deploy it.
To put this bottleneck into perspective, think about traditional enterprise software for a second. If you're building a fraud detection model or an intent classifier, success is pretty straightforward to measure. It's closed-ended. Did we save money? Yes or no? But foundation models, they generate open-ended text. How on earth do you objectively score a summarized legal contract, or a generated poem for that matter? This open-ended nature just completely breaks our traditional closed-ended testing methods.
Which brings us to Section 2, evaluation-driven development. Since our old testing methods are broken, we need a complete paradigm shift.
This shift is what we call evaluation-driven development. Now, if you're coming from traditional software engineering, this is going to sound super familiar. It's directly inspired by test-driven development, or TDD, where you literally write your tests before you write the code. In the AI world, evaluation-driven development means you absolutely must define your evaluation criteria before you sink precious time, money, and caffeine into building the app itself. You have to know what the final exam looks like before you try to pass it.
Now, you might be tempted to just stick to building apps that are easy to evaluate. But doing that is exactly like that old joke about the person looking for their lost keys under a street lamp at night. They're only looking there because the light is good, not because that's where they actually dropped the keys. If we only build what's easy to measure, we are going to miss out on massive, game-changing generative AI use cases simply because we were trying to avoid the hard work of evaluating them.
So moving right along to Section 3, defining your evaluation criteria. Let's talk about how we actually shine a light into the dark and figure out what to look for.
When you're setting up these criteria, you generally want to think in terms of four main pillars. First is domain-specific capability. Basically, if you're building a Latin translator, the model fundamentally needs to know Latin. Make sense? Second is generation capability, measuring things like, is this coherent? Is it faithful? Third is instruction following. Does the model actually respect the very specific formatting constraints you gave it? And finally, cost and latency. Because look, if your model generates a perfect SQL query, but it takes 10 minutes and costs $5 a pop, it's virtually useless for a fast-paced business.
Let's drill down into that second pillar, generation capability, for a second. We need to talk about factual consistency, because let's face it, AI hallucinations are a massive headache. You can evaluate facts in two ways, against general, open-world knowledge, or against a very specific, locally provided context. And this is where it gets kind of wild. If you feed the model a specific document that literally says the sky is purple, and the model outputs the sky is purple, that's actually considered locally factually consistent. It followed your specific local context perfectly, even though it completely defies real-world facts.
And this brilliantly illustrates how we can handle that third pillar, instruction following. Adapting from the IFEval benchmark, we can actually use automatically verifiable instructions. You can write a hard, programmatic test to see if a model included a specific keyword, or if it hit an exact word count, or if it successfully avoided forbidden words for safety reasons. It gives us this really nice, highly objective, and completely automated way to score the model's behavior.
All right, Section 4. Automating with AI judges. Let's be real. Relying on a human to sit there and read every single piece of open-ended text to score it is painfully slow and expensive. We need scale. Get a load of this number, 58%. According to LangChain's State of AI report for 2023, 58% of the evaluations running on their platform were actually done by AI judges, an AI grading another AI. That used to sound like total sci-fi, but post-GPT-3, it is highly practical. In fact, it's arguably the most common way engineers evaluate models in production pipelines right now.
But an AI judge is only as smart as the instructions you give it. If you want this to actually work, your prompt needs 3 mandatory elements. First, the task. Be explicit. Say something like, evaluate the relevance between this generated answer and the user's question. Second, the criteria. And this is huge. The more detailed your criteria, the better your evaluation. Actually, scratch that. Just saying be critical isn't enough. You have to literally spell out how to determine relevance based on the facts. And third, you need a crystal clear scoring system, whether that's a simple good or bad, or a scale of 1 to 5. Now, when you start playing around with AI judges, you're going to see that platforms offer a bunch of built-in criteria. Azure AI Studio has things like groundedness and fluency, while LangChain might focus on safety, with metrics for harmfulness or misogyny. But here is a massive warning label for you. These criteria are absolutely not standardized across the industry. A relevance score of 4 on Azure might mean something entirely different than a 4 on MLflow. It all depends on the specific underlying model they're using and the hidden prompt running behind the scenes.
Okay, Section 5. Navigating model selection. You've got your evaluation pipeline built. Now you actually have to pick a model. And the landscape right now is kind of a jungle. The biggest choice you're going to face is between proprietary model APIs and open-source models. Proprietary models are fantastic for getting started fast, but you're entirely locked into that one provider's service-level agreement. If they go down, you go down. Open-source models, though, they give you incredible flexibility. Multiple providers host them, so you can shop around for the best price, and it's way easier to crack them open and manipulate the internal components if your specific app needs it. Naturally, you might think, I'll just go check a public leaderboard to see which model is best. So the crucial point here is, beware of contaminated public benchmarks. There are thousands of benchmarks out there for math, reasoning, coding, you name it. But because the test questions are public, they often end up getting scraped into the training data for the newest models. The models have basically seen the test answers before they even take the exam. So while public benchmarks are great for weeding out the truly terrible models, they are almost never going to tell you which model is the absolute best for your very specific use case.
And that brings us to the final question I want to leave you with today. Are you just surfing the hype wave and relying on public benchmarks, or are you actively using evaluation-driven development to build your own private leaderboard? By doing the hard work to define your unique criteria up front and maybe deploying AI judges to scale it all up, you can rank models based on exactly what your application actually needs. It's time to stop guessing if your AI works and start proving it. Thank you so much for hanging out with me for this explainer. Keep building, keep evaluating, and I'll catch you next time.